Hello everyone, welcome to our project. Our project's name is Visual Aid for the Disabled. My name is Jai Kamdar and I have my teammates Samruddhi Pai and Shaival Parekh with me. The project guide for this computer vision project was Professor Darshana Sankhe. Moving on, our problem statement is basically a wearable product which can be used by the disabled in order to detect obstacles. So to break these things down into objectives, then the first thing would be to recognize objects and identify them and classify these objects as living or non-living. The classification is important because if there's, say, a blind person walking, and if there is a living human being standing in front of them, then he will definitely move from his path to allow the blind person to walk, and he won't necessarily be an obstacle in his path. So after classifying these, we will be perceiving the depth of the object from the human. Now that depth is going to be a relative depth with respect to all objects, so that the algorithm can provide feedback signals via a sound output. In the end, what we aim to develop is a portable and a wearable product by the disabled person, so that it can be useful for him wherever he goes. Going on, I will be explaining the proposed idea and system implementation. We first acquire an RGB image, that is a red, green, blue image, and feed that as an input. We then pass that image to an object detection block where we use YOLO algorithm, which does the recognition as well as the classification. Moving on, we will be using the distance measurement block, which will be calculating the distance of the detected objects using monocular distance measurement approach. What that means is basically it will only be using a single camera in calculating the relative distance and giving the feedback output. Based on those pixel values, we will be defining a region for that particular obstacle. Where is it exactly on the frame? Is it in the middle of the frame, left hand side, right hand side, so that the necessary feedback actions can be given. This perception of the surrounding is going to be given out as an audio feedback, and that is entirely our system implementation and idea. Moving on, I will be having Shaival will be explaining the object classification and the camera calibration part.
Hi, so when we start working with the camera, it is not calibrated. So it has various errors like radial distortion, angle distortion, and various other problems. So first we need to rectify them. For that we do camera calibration. In this we click a photo of a chess board from different angles. We click at least 50 photos and calibrate it to match out its intrinsic and extrinsic parameters. Thus, this removes all the distortions and gives a clear output. This is necessary to generate images on which we can do some processing. After calibration of our camera, we move on to object detection and recognition. So for this, we use the YOLO algorithm, which stands for you only look once. This works using the MS COCO data set, which contains up to 80 items like cats, dogs, cars, buses, etc. Uh, this algorithm works on convolutional neural networks and TensorFlow. So this makes it very fast and very efficient. We have tried to make our system as close as to real time as possible. So for that we use this algorithm. So after object recognition and detection, we move on to distance measurement, which will be explained by Samruddhi.
After detecting the object, the next task was to calculate the distance of those detected objects. So for calculating the distance, we had three algorithms. One was stereo vision, the second one was using disparity maps, and the third one was using monocular vision. So we chose to use monocular vision algorithm as it requires only single camera. So that would make our final product more compact and cost efficient. So one of the drawbacks in monocular vision was that it requires height of the objects that is being detected. So to overcome that drawback, we made a dictionary which has average heights of all the objects that are present in our classes. So monocular vision basically works on the Lenz's law. As you can see, there are similar triangles are being created. So if we know the focal length of camera and the height in pixels of the object that is being detected, as well as the actual height of that object, which is the average height in our case. Then we can calculate distance by using similarities of triangles. The next task was to locate the position of object with respect to the person. So considering person to be standing on the central axis, we divided the entire image in three parts: center, right, and left. So accordingly, whichever the object is being detected, we calculate the distance, and the object that has relatively minimum distance from the person, uh, its location is identified uh, based on where it lies, whether it is in front of the person or towards right or left, and the audio output for the same is given. The objective of taking only the object that is closest to the person was to avoid excessive noise, and if we keep on giving audio output for each and everything that is being detected, then that would irritate the person. So we choose only the object that is closest to the person.